Hey guys, welcome back. We are continuing our stoichiometry unit, and just like the units or the lessons before, you want to make sure that you have completed the previous lessons before doing this one, because again, if you didn't do yesterday's lesson, today's will not make any sense, because you need to make sure you understand percent composition before you can do empirical formulas today. Okay? So with that caveat out of the way, let's go ahead and get started. Today we're going to be able to use our mass and our percent comp to create a chemical formula. So in the past, whenever I have asked you guys to determine a chemical formula, it's usually been either from the name of a covalent compound like carbon dioxide, or it's been an ionic compound and you use your swap, drop, and chop method, right? So you know the charges of the ions, you swap, drop, and chop, and you can tell me how many atoms of each element are in the compound. Well, today we're going to be able to figure out how many atoms are in a compound based on the percent composition of each element in the compound. So let's go ahead and get started. So today we are learning how to write empirical formulas. So this is basically the reverse of percent composition. So we're going to take what we know about percent composition and we are going to determine the formulas of a compound. So basically how many atoms of each element are in the compound. Okay. So here's an example. We have our H2O, right? And then we learned how to do this in yesterday's lesson. So we learned how to figure out the percent of each element, right? We have to find the molar mass of each of the elements, and then we have to divide by the whole, right? The whole molar mass. So if we did that for H2O, we would find that there would be 11.21% of hydrogen and 88.79% oxygen. Again, if you have no idea what those percentages came from, you need to go back and make sure you feel good about yesterday's lesson. So an empirical formula is the percentage of each element. We're going to use that to help us determine how many atoms of each there are. Okay. So for example, here in carbon dioxide, if we had a formula that was 27.29% carbon and 72.71% oxygen, we would be able to use that information to determine the chemical formula in the simplest form. So what I mean by that is that all of the subscripts are no longer divisible by a common factor, and it's in its simplest form. Okay, so I'm going to show you how to go from this, so the percentages, to the formula today. Okay, yesterday we went from formula to percentage. Today we're doing the opposite. We're going from the percentage to the formula. So let's look at an example and look at the steps of how we do this. So this question says, find the empirical formula for a compound with 25.31% magnesium and 74.47% chlorine. Well, what are we going to do? These are the steps we're going to follow. Step 1. We are going to convert all of our percentages to grams. So in this case, we will assume we have 25.31 grams of magnesium and 74.47 grams of chlorine. Step 2, we are going to determine the number of moles for each element. So we're doing a mole conversion here. So we are going from grams to moles. So we will need to use our molar mass. Again, that comes from the periodic table, the average atomic mass. So we're going to convert our grams to moles. Then we are going to divide each by the smallest number of moles. Okay, so we're going to divide them by the smallest number of moles. And then we will use those answers as the subscripts for each element. So what we mean by divide by the smallest number of moles, let's say we work this out and we come up with like 1 mole magnesium and 3 mole chlorine. Everything would get divided by 1. Okay, it'll make a lot more sense once we go through some examples here. Okay. Then, if it's necessary, you need to multiply each value by an integer to obtain a whole number. So in empirical formulas, these are the simplest forms, but remember, you cannot have decimals. We have to have whole numbers. So if you're coming up with numbers like 1.5, you're going to have to multiply it until you get to a whole number. Okay, so let's take a look at some examples. So again, we're going to do the same problem. We're going to find the empirical formula for a compound with 25.31% magnesium and 74.47% chlorine. Okay. So the first thing we need to do is just convert to grams. So we're going to assume we have 25.31 grams of magnesium and 74.47 grams of chlorine. Now we have to convert from grams to moles. So we have to go from grams of magnesium to moles of magnesium, and from grams of chlorine to moles of chlorine. So we're going to do magnesium first. So remember, when we do a mole conversion, or grams to moles, we always start with what we know. So we're starting with 25.31 grams of magnesium. We want to eliminate grams, and we want to be left with moles. So remember, when we're doing these, our unit we want to eliminate always goes on the bottom. The unit we want to keep always goes on the top. So we'll have mole on the top, gram on the bottom. And the 1 will always go with the mole. So we're going to have a 1 mole on top. And then we're going to have grams on the bottom. 1 mole of magnesium will be equal to the average atomic mass. So the number that we're going to see comes from the table. Okay, so 24.31 grams of magnesium, again, that comes from the periodic table. It's that average atomic mass. Okay, and this is just what we did earlier in this unit about gram to mole conversions. Okay, so if we do that math, we would do 25.31 times 1 divided by 24.31 grams, which will give us 1.04 moles of magnesium. Okay, so again, these are just fraction problems. You multiply through the top, multiply through the bottom, and then divide. So it would be 25.31 times 1 divided by, there's an imaginary 1 here, 1 times 24.31, which just winds up 25.31 divided by 24.31. Okay, so that means in this problem we have 1.04 moles of magnesium. Now we have to do the same thing for our chlorine. So 74.47 grams of chlorine. Again, we want to go to moles, so our moles will be on top, and our grams will be on the bottom. So every 1 mole of chlorine is 35.45 grams. And again, this is the average atomic mass from the table. So this comes from the periodic table. You got to go find it. And if we do that math, we get 2.10 moles of chlorine. Okay, so 74.47 divided by 35.45 is equal to 2.10 moles. So now we've done steps 1 and 2. Step 3 tells us to divide each by the smallest number of moles. The smallest number of moles here is 1.04. So we're going to do 1.04 divided by 1.04, and then we'll do 2.10 divided by 1.04. So with magnesium, 1.04 divided by 1.04 equals 1. And for chlorine, 2.10 divided by 1.04 is going to be equal to 2. Okay? So what we'll need to do is then use this number as the subscript for the formula. Okay, so we're going to use the answers as the subscripts for each element. So the 1 will become the subscript for magnesium, and the 2 will become the subscript for chlorine. So our empirical formula is Mg1Cl2, which again, this 1, we usually don't write a 1, so it would just be MgCl2. Okay? So again, if I were you, I would at the very least, when you're doing your notes this week, make sure you have all the steps labeled in your notebook and have at least one example in there, because that is going to be the biggest thing with these, is that you need examples that you can follow and that you understand. Okay? Let's do another problem here. So it says automobile antifreeze is composed of 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. Determine the empirical formula. Well, step one, we got to convert everything to grams. So we are just going to do 38.7 grams for the carbon, 9.7 grams for the hydrogen, 51.6 grams for the oxygen. Okay, that's the easy part. Step two, we got to convert everything to moles. So let's start with carbon. 38.7 grams of carbon. We want to eliminate our grams. So our grams will go on the bottom. Our moles will go on the top. So it'll be 1 mole over the molar mass of carbon, which is also the average atomic mass because there's only one atom of carbon. So that's 12.01. So we would do 38.7 divided by 12.01 will give us 3.22. Okay. Next we have hydrogen. 9.7 grams of hydrogen times 1 mole of hydrogen over 1.01 grams of hydrogen. Again, average atomic mass coming from the table. 9.7 divided by 1.01 will give us 9.60 moles of hydrogen. And then same thing for oxygen. So we've got what we started with, what we know. 1 mole over 16 grams. 16 comes from the table. 3.22 moles. So now our smallest number of moles is going to be 3.22. That's for the carbon and the oxygen, which just means that's going to be what we divide by for our empirical formula. So if we do that, 3.22 divided by 3.22 is 1. 9.60 divided by 3.22 is 3. And then 3.22 divided by 3.22 will also be 1. Okay, so that means our formula will have 1 atom of carbon, 3 atoms of hydrogen, and 1 atom of oxygen. Basically, all this is just ratios. We're figuring out the ratios of the atoms in the compound. Okay, so that would be C1, H3, O1, and of course, because we don't write the ones when we just assume that they're ones, it would be CH3O. So that would be your empirical formula of this particular percent composition. Okay? And those are your 2 examples in your notes for today. Again, you know, I think at this point you guys are probably realizing, because we're on lesson 4 now, everything in this unit builds on itself. Everything. So like if you missed, you can't miss a lesson in this one because you have to know how to do all the conversions and then of course build on it each day. So if you're having trouble or if you have gotten behind and you need to meet to help catch up, please let me know because I would rather catch it early than have you struggle through this entire unit. This unit, I don't want to say is difficult. It can be difficult if you get behind. It's just a lot of practice. So the more that you practice, the more comfortable you'll get with these problems. But of course, if you need help or would like some additional tutoring, please let me know. But with that, you guys are good to move on to your graded assignment for the day, and I will catch you guys in your next lesson.